Okay, welcome back. So this one's on solving inequalities again, but now there are two variables. There is going to be an x and a y variable involved in these ones. All right, so the way we handle these questions, and I'll show you what it even means because it kind of means something a little bit different than it did before. Before, we had like a graph like this and we wanted to know where that was positive. Now when we have a y involved, what's going to happen is we're going to be looking for everything like in between the graph right there, right? Like it could be all those numbers in between. There's way more numbers that could be now, just not just along the function. Okay, so that's where we're headed. The way we do these, so for this one, it says solve for y, keeping the y variable positive. What I mean by that is if, let's say we had a question like, I don't know, x minus y plus 2 is greater than 0. And it said, so first step number one is we want to solve for y, make an expression with y. The first thing we want to do is keep the y variable positive. So what we do is just bring the y over to this side first. You don't want to wait till the end and then divide by -1 because that ends up messing up our symbol. You'd have to swap the symbol. You have to switch it for a less than symbol if you were going to do that. It's a lot simpler if we just take this term to begin with, keep it positive, and then we can keep this symbol pointed the same direction. So step number one, move y to the other side if it's negative. Okay. So in this case, though, we've got 3x plus 2y plus 6 is greater than 0. It's already positive, so I'm just going to solve this like I normally would. So I'm going to bring, so this would end up being 2y is greater than negative 3x minus 6. And then I divide everything by 2, so we'd end up with y is greater than negative 3x minus 6 all over 2. And I'd like to make this, I don't really like the all over 2 thing, so I'm going to rewrite this again, a little bit more simplified. This is really negative 3x over 2 minus 6 over 2. So that is y is greater than negative 3x over 2 minus 3. All right, and I stupidly wrote this right in the middle so I don't have much room to do the rest of it. I got lots of room over here. All right, B says graph, just like you normally would in your calculator, graph y is equal to. So this, I can actually just graph this in my calculator, and I'll show you how to do that. So if you graph it like you normally would, you end up with a line looking something like this, right? Technically, our line should be, so technically our line should be a dotted line, but in my calculator, wherever it is, there, I've just said y is equal to, right? So I've got the equal symbol there. But I'll show you, you can actually have this function in your calculator too if you have a TI Inspire, where I can change my equal symbol to look just like my equation. So y is greater than, oh, I got a multiply symbol in there. Y is greater than this function. So if I do that, you can see that this is how my graph changes. It's saying that, you can see it's a dotted line now too. The calculator knows it should be a dotted line. And it's a dotted line because, and it's all because, our original equation or says y is greater than. It doesn't say that it's equal to. So it would be a solid line if this said y is greater than and equal to, but it's just greater than. So it's never actually touching that line. You could say it's always just greater than that line. So go back to our graph. This is what's happening. So when you come up with this equation that we just came up with, we're saying that y is everything to the right. All this blue shaded area is what y is equal to. So with two variable equations, this is my solution. Like this is my final answer, right? I just rearranged this. My equation, instead of being like a line, we usually say like y is equal to something something x yada yada yada, and you're talking about a line. With inequalities, we're saying y is greater than that line. So y is everything over here. I know it's a little bit different and maybe a little strange to get used to, but that's what inequalities are saying. They're not saying that it's a line, like following that line. It's saying it's everything above that thing. All right, so the next thing you need to do, though, so for part C, is we need to check to see if we're right. So the way we do that is by just grabbing a test point. So if we grab the test point, let's say right here at the origin, 0, 0. So we know that x is 0 and y is 0. So go back to the original equation and plug in 0 here and 0 here. So if we do that, we'd have 3 times 0 plus 2 times 0 plus 6 is greater than 0 so far. So what we're really saying is that 6 is greater than 0. That checks out. 6 is greater than 0. So that test point worked. I'll just show you a situation where it wouldn't work. Let's grab any other test point. Let's grab the test point of maybe right here at -3, 0. So -3, 0. So x is -3, y is 0. So we'd have 3 times -3 plus 2 times 0 plus 6 is greater than 0. So we've got -9 plus 0 plus 6 is greater than 0. -9 plus 6 is -3 is greater than 0. That doesn't make sense, right? That doesn't check out, which proves that's right. That's on the wrong side of our inequality. So that shouldn't make sense. That shouldn't be true. Okay, so we've already done D as well. That's just shading the region that we did on that side of the graph. So I'm going to let you guys go ahead and do number 2. I would just recommend moving the -2y over to the other side first. Don't move the x over this way. Move the y over first to keep the y positive. That's just going to make everything simpler. Okay, and then graph it, do a test point, and shade the solution or the area. One thing I just want to help you, I'm going to let you guys do this one too, but I just want to kind of show you what's happening. This one says solve y is greater than x squared minus x minus 12, which is less than 0. What does that even mean? Well, if I show you the graph, it might make a bit more sense. So what it should be is that y is greater than this function. You can see since it's just greater than, it's just a dotted line again. And actually make this bigger. Okay. So y is greater than, so that's the shaded area, right? But then the next part of our thing says that this is less than 0. So what we're really interested in then is everything below the x-axis. So it's the shaded area inside the parabola, but below the x-axis, because this is all less than 0. So that's what that means. Okay, so I'll let you guys go ahead and do that question as well. So this last one says, what is a major difference between solutions for one variable and two variable inequalities? And I find it helps with a graph. So one variable inequalities are talking about along that line, where is it greater or less than 0 if it was 0 that they were talking about. So it's talking about actually on the graph. That's one variable. Two variable. Sorry about the bad writing. Two variable is that whole shaded area thing. So that's going to be more along the lines of, it could be the shaded area inside that parabola, or if it was saying less than, it could be the outside, and you need to find that point. So that's pretty much it, one variable and two variable. The text questions, I'm going to put them on the website, so make sure you guys do the text questions on the website. And I'd also like you to finish these questions. These are more one variable inequalities, so like the ones at the beginning, so the last video. You can use the chart method. I'll also let you use the graphing method, which is probably a little bit simpler, but make sure you know both. Okay, so that's it for that video, and I'll see you guys in class.